All right, welcome back, everyone. Now they're a little bit familiar with subnetting and IPv6 addresses. So we're going to go ahead and address now in our PCs and our routers what addresses that we need to put in there. Now, normally, I've always put 2001 across the board, right? But that's not what I'm doing now anymore, okay? When I'm creating LANs and WANs, because when you're going from router to router, we assume WAN. All right, you don't have 10 routers in one building unless you're a data center. Okay, normally we have one or two routers within a building, and then they get routed across the wide area network to some other branch or what have you. So what I do now is I'm going to start using the FD, all right, 00, because it's a unique local address, and I'll use a public address, 3000, let's say, all right, and then we're going to go ahead and start addressing our routers and our computers. Not difficult. Again, the focus is on the network prefix, not so much the interface ID, because with the interface ID, you can use DHCP version 6. Okay, you can use auto configuration, EUI 64. You can just use even the link local if it's point to point, all right? Because those are the APIPAs, which it replaces the APIPA, but you can do it. You can actually network point to point, but they're not routable addresses. So really, what a lot of people do is use the EUI 64. I'll just put a normal, easy, static address at the end. Now go crazy, just put like 1, and then that's it, or 2, or F, or whatever. That's what I do. All right, if you can do things statically. You're going to do things statically, but it's the network prefix is what we need to focus on. So in this particular lecture, okay, which is addressing our devices, all right, that's what you need to focus on. And again, it's the network prefix that's the most important. I'll see you inside. Hey, welcome back, everybody. Now that we have a basic, hopefully, basic understanding of IPv6 addresses, all right, we know they're 128 bits long. There's basically 3 types. There's a lot of types of IPv6 addresses, but we put them in this particular category of a globally unique address, a unique local address, or an anycast address. All right. Globally unique obviously means public IP addresses that are globally, they're routed without the use of NAT, that you'll be able to go out onto the internet because these are public, unique IPv6 addresses that are assigned to you, all right? And if it wasn't clear in the first lecture, let me be clear now. Let's open up Notepad here. I have a Notepad. So globally unique addresses can be 2000, okay, ::3, all right, or let's just say this, they can start with a 2 or a 3. So anything that starts with a 2 or a 3, all right, because they give you a range for, if I'm not mistaken, for globally unique addresses that go from 2000 all the way to 3FFFFF. Okay? So, but this first hex digit is what we need to understand, because they're giving you, as far as globally unique addresses, that you're using a particular length, okay, a bit length that you can go ahead and use. And again, going off memory, it would be, I believe it's a 3. Use the first 3 bits of that hexadecimal digit that we see here on our screen, as that would be 3. Okay, because if you look at it, this would be 000. I'm sorry, 00010. That would be, because this is 8421. That will be 3, And then if we go here, from here it's 0011, right? That would be, that would be 8421, 8421, and 1 plus 2 is 3. So if the first digits start with 2 or 3, all right, those will be a global unicast address. Now, if you go to the pages that I showed you, like this one here, let me go to it real quick. Here is the IANA, right? IATF, whatever. This is the actual RFC, okay, which is RFC 4193, which in your book, in page 551 of volume 1, it says that, hey, you know, the INA actually reserves the prefix F00, FC00::7, and not FD00:/8 for these particular addresses, for the unique local addresses, okay? But it also states in RFC 4193 requires the 8th bit to be on. What does that mean? I mean, you can read this for yourself. It's RFC 4193. And this is one of the things I believe when you're studying for this new exam, you need to fully comprehend. When you're using a unique local address, because this will be considered here global unique address. This is an address that's globally known, that's unique, that will allow you to travel throughout the internet without the use of NAT or anything like that. Okay, or you would actually go to an ISP to get a global prefix, right, from your ISP or what have you, not the IANA, but your ISP themselves. Okay, and it will give you, you know, it could be the first 32 bits of the address or the first 48 bits, okay, of the address. In the book, it states you can go as far as 56, which that is going to fall into the range of the subnet, in the section of the subnet portion of it, which I don't agree with. And again, this is my personal opinion, not Cisco's, okay? They say FC, okay, or FD. But FC, all right, has 1, 2, 3, 4, right? That's the F. Let's separate this, so we don't have no confusion. All right, this is FC. This right here. This is the F, okay, and this would be the C. C is what? A, B, C. It's the third. So 10, 11, 12. So 12. So that would be 8 and 4. That's 12, 0, 0. So if you look at it, this is 4, 5, 6. But they're saying here for an FC, you can use a 7 bits. 7 bits. FC00. Right? Let's just call it that. FC00. Let's call this guy FD00, like they ask you in the question in your book. FC00::7. Well, F is this. Because if you add 8421, that's 15. And you go to the next one, 8, 4, wait a minute, what's 8 and 4? 8 and 4 is 12, is it not? And 12 is ABC, okay? That would be 10, 11, 12. Okay, it goes up to 9, then 10, 11, 12. That'll be ABC. So really, is these two, this is 6 bits, not 7. So they're actually going for, 4 to 1. They're saying that this particular portion, the 7 bits, the 7th bit is set to 0. It's set to 0. All right, or in your book it says that and RC 4193 requires that the 8th bit of these addresses for the FD the 8th bit of these addresses to be set to 1, which means that in practice today, the unique local address all begin with the first 2 digits or hex digits as FD. Well, let's convert FD into what it is. So the F, 1, 2, 3, 4, 5, 4, sorry, that would be F, right? And if I come here, right, 8, 4, 2, 1, that's F. No doubt about it. And then we go to the D portion of it. So we got, let's go down here and go 4, 2, 4, 8, I'm sorry, 8, 4, 8, 4, 2, 1. Okay. So that's 1. So if C is 12, okay, let's see, A, B, C, D, that's 4 bits on. That's 4 bits on. A, B, C, D, 9, 10. Oh, sorry. Okay, this is 12. And then, yeah, that would be off, obviously. Yeah. This, so yeah, that's C, right? See, A, B, C is 12. Okay, A, B, C is 12. Yes, here we go. We got 12 here. And then here for FD is A, B, C, D is 10, 11, 12, 13. So that would be 12, 0, and 1. So they're correct. They're correct. The 8th bit has to be on, where here it's off. Here it will be on. So you use this. That's why it's ::/8. Sorry, /8. Okay, you will use it for unique local addresses. Now, this is what they state here in your book in page 551, that these are the addresses that are being used today. And these addresses are not routable. They're not routable, okay, unless you're using NAT to get across or what have you. Now, obviously, when we're using the packet tracer, we really don't need NAT. We're showing the routing tables. You don't have to do that, okay? But either FC or FD, the main difference is that with FD, which it took, some Sherlock Holmes detective stuff to find out this information, all right, for FD. Because if you look at the IANA.org, which you guys have seen, all right, it just talks about FC, all right? But I did find there's one image which is out online, and it says unique local FC00/7 FDFF/7. That's not true. That's not true at all. At all. The FD would be 8. It says it right here. On RC 4193 requires the 8th bit of these addresses to be set to 1. And it has to be. Because if you want to get it 13, which is what that is, you have to add 8 and 4 is 12, and 1 is 13. That's how you get D. That's how you get D. This is how you get F, right? All in on. But that's how you get D. So you need to understand that this is why converting hex numbers, all right, I understand, and to decimal, binary, whatever the case may be, you need to understand that. You need to understand that IPv6 addressing is 4 bits long. So, when it comes to the test, memorize whatever the hell the book says, okay? I'm just doing detective work in case anybody just asks me questions, and obviously for this particular lecture that I'm doing for you for your course. But so you can see where these prefix lengths are coming from. All right, these prefix lengths, because you have prefix lengths that are 128 bits long. Well, that's a specific address, like the loopback, okay? The loopback address is, ::1 with a /128. Well, that's because it's the whole damn address is, that's it. There's no other address. So you gotta be careful when you're researching out there, where do you go? Because that picture that I showed you, this one right here, they're wrong. They're wrong. It's not 7, it's 8. According to the RFC 4193, they're wrong. All right, but anyway, the whole point is that you can use either FD or FC for unique local. And your book does talk about that not all FDs are reserved for local, okay? but you can use them for local, and they are not routable addresses. These are considered locally ULAs, unique local addresses. Unique local addresses that are, the same as private IPv4 addressing that you would need not in a real world scenario. In a real world scenario, you would need in order to get outside. Now, I hope that I hope you're understanding this. All right, because this is how they're coming up. You have from the 2 to the 3. Anything that starts with 2, and I'm just going to put all zeros here, 0, 0, 0, and then I believe the furthest range is FFF. So anything that starts with a 2 or starts with a 3, and here's how we get the 2 using here the hex, the conversion. Here's how we get a 3, right? It's 4 different bits in one hexadecimal digit. This is how you got the 3. Okay, so you need to understand that, because when you start studying for the different types of addresses that exist, they're talking about, well, one's 40 bits, one's 48 bits, and the first 2 bits or the first 8 bits are on here, and the other 8 bits. So it all depends. Basically, you need to just freaking memorize what the IPv6 address is. What we did before in the older CCNA, these are the type of addresses that we use, okay? These are anycast, these are multicast, these are, unique local addresses, these are global addresses. That's it. And then how, assigning these addresses to your PCs and to your routers. All right. Obviously, the way I would do it in my previous lectures, right, in a particular lab like this, I would assign, let's put here, I would go 2001:3200 BADD 1000 and then let's say I would use normally like a 56 as I would actually subnet, but let's just put a 64. Okay, a 64. All right, and then that will be the end of that, right? That will be that particular network. All right, and then I will do that network for even your LAN, and then across the WAN, and then for this LAN. That's how I would do it. But I'm not going to do that for this particular test, for this particular certification. If you go to this PC here, you're going to maximize it. All right, and I'll go here. I'm going to see the IP address. Look what I'm using. I'm using an FD 003200 bad 1000, and then the actual interface ID I'm putting as a 1, and I'm using a 64. Okay, and then the gateway FD, right? Because it's local to the LAN. That's going to be my gateway, and then that's going to be an F. But you can see here, all this remains the same. All this remains the same. Okay, the same subnet, 1000, right? The global prefix, right? The 48 right here, all right? They're all the same. So they're all in the same subnet. Okay, so the only thing that changed was this guy right here, which is in the interface ID portion of the address. This is 1, this is F. I'm using a 64-bit, meaning my line is right there, right before those 2 colons, right there. That's where my line is at, slider 64. Okay, so I'm using that for that. So when I come over here, maximize that. Same thing. This is just 2. And then F, but it's still the 1000, right? We're still using the 1000 subnet. This is 1 VLAN right here. So we're all part of the same IPv6 address. Let me delete this. This is how I used to do it. I'm not doing it anymore like that. Okay, so I put an FD, and I actually put a unique local address of FD on all my IP address, on all my computers. This is, ::1, ::2, ::3. But the gateways are all Fs, right? So if you go to this router right here, I'm going to maximize the screen. And I do enable. And let's do a show start because you can probably see it better. Okay? You see, I already did rip and everything. IPv6 address FD 3200 bat 1000 F. That's my gateway. I'm using a 64. All right. And then when I go across though to the other router, I'm using a public, because this is a public site, supposedly, of the address, right? So I'm not using it anymore 2001. I'm going to use a 3, because I feel like it. I can do whatever I want on IPv6, right? So this is 3,000, 3,200 bad. And then you can see here, I took out the leading 0, 400, colon, 1, and I'm using a 50. All right? And I know that because I subnetted it. And this is one of the addresses that you saw in my previous lecture. Okay? And then I come over here, maximize that, do enable, show start. Okay, and I have the same thing. Here's your 3,000, but now instead it's still 400. See how they're all the same. They're the same subnet, the same globally unique address. All right, the other thing that changes is this guy, the interface ID. Previous length is still 50. All right, which is up to here. Okay, previous length is still 50. Nothing's changed. Okay, and then I have my, now here you see it's not 1,000, now it's 2,000. It's a different subnet, a completely different area. Now I'm still using FD003200 bad, but my subnetting section, I decided, I'm going to go, since I'm using a 64, well, what the hell? I'm going to use 2. So there's 2,000, and that will be my F. Okay, that will be my F. So when putting these addresses in there, if you want to follow a book, okay, I said, you know what? I'm going to go ahead and put a unique local address, actually put a unique local address on there. All right. And then I'm going to go ahead and put one of the, the range from globally unique addresses up here. So apparently I can go, look at my range now. Look at my range. I can go from all the way from here to here. Okay. So, all right. I've always been using 2,000. Well, now I want to use 3. Okay. And again, this is something I can do because it's a lab, whatever. Obviously, in the real networking environment, you're not going to be playing around with that. That is the IANA, and then your ISP gets whatever here, and then your ISP will give your company whatever here, and then you decide where the hell you want over here, okay? Internally. And that's what I did. And then I enabled RIP. And again, even though RIP is not one of the routing protocols that you will be doing in this new certification, it's just a really quick way of doing it, because to enable RIP, all you gotta do is go into the interface and literally just type this. You go into the interface and just type that. That's it. You have to do nothing else. Type that, it creates this. All right? And if you look at the routing table, the space here, show IPv6 route, you see that I'm routing. You see that I'm routing. Okay? And if I copy this, I'm going to copy this right here. I'm going to go to the server, which you see that it has that, okay? And I'm going to go over here, and you see I already tested it already. All right, and I'm going to ping. Well, I ping the gateway. Let's try to ping the computer. All right, and let's ping 1. And I can ping. Okay, that is going from a locally a EULA, right? Unique local address to a 3000, right, which is a public address going across the WAN. Okay, supposedly this is the WAN, okay, and then going to another local address. Now, when you are configuring these things on your routers, there are certain things that you do need to type. And I'm just going to put up here, I'm going to bring out a router just to show you. I mean, even if you're just working on IPv6, this is something that you need to do, period. It's just a good thing to do. I mean, because if you're not routing or anything, if you're just doing things locally on your segment, you're playing with yourself, okay, that didn't come out right. You're just playing around with yourself. No, that didn't come out right either. Well, you know what I mean. All right, you're not going out to the internet, okay? One of the things that I always urge you, just type in IPv6 unicast routing. Just type that, okay? Because if you don't type that, you're not going to be able to route an IPv6. And if you're doing IPv6, eventually we're going to route. I mean, really, who's not routing an IPv6? Pretty much everybody. Nobody has fallen in love with IPv6 yet. Not even my own provider, okay, has fallen in love with IPv6. They have no idea what the hell they're doing with IPv6 or wireless, but that's another story. But not all ISPs, all right, we have not yet gone to that point where we're, I don't think we're even 60% or even 50% complete of changing things around to IPv6. It just is not happening. It would fix a lot of issues, but again, we have the experienced 30, 40-year veterans have been around since the days of, I don't know what, dot matrix printers and DOS, all right, that do not want to learn IPv6, just like when we went from NT4 to NT5, which is Windows 2000. It was a battle. It was a battle. Yes, it was a huge battle. And now, going from IPv4 to IPv6, that's even a greater battle. Might as well call it World War X, because this is like, whoo, to the 10, right? To the power of 10, because it's just a long address, and there's just so many different types of IPv6 addresses that are being used for different types of services, just like the Anycast address, right? You got to type Anycast after it. But anyway, so in order to route in IPv6, you need to type IPv6 unicast routing. And then let's see what interfaces I have. You do show IP in brief. Yeah, I'm not connected to anything. But we have the F00, int F0. Let's see what it'll allow me. F00. IPv6 address. And then you just go ahead and knock your socks off. Let's use a 3. Why not? Let's use 3.1. Right? We can. Right? We can go to 3FFFF. Right? So 3.1.0.0. Right? Colon. I don't know. Let's not use 3 again. Let's use something different. Let's use what they use. DB8, right? They love using this one, DB8. This is for referencing, right? Only referencing. There's a 0 in front of that, but we omit the zeros in the front. Okay? And then, who's your company? I can't put docs, obviously. All right, let's put Facebook. Okay? And then we're going to put whatever subnet we feel like it. Okay, so we're just going to put this. Just make 1, 2 main zeros. Make life easy. We're going to do colon. All right, and you have a choice now, because we really don't really care. I mean, as far as the interface ID, there's so many, you can do it statically if you want. Go ahead, start playing, start mixing, matching numbers. It's up to you. All right, just don't, statically would be just insane. But well, you can. Or you can use DHCP, you can use, I'm going to do this. :/64 EUI-64. All right, and what that's going to do, we should already know this, all right? If you're coming from the previous CCNA, I'm going to do the no shut, turn on that interface, even though it's not connected to anything. All right, what's it going to do? Look at the front here. Do show IPv6 int brief. Okay, you see it's getting. Here's what we just used, right? That's the network prefix right there. And this guy right here is the interface ID to make this 2 as well. The 2 is the UL bit, it's the 7th bit. It got turned on, okay? That's why that's 2, okay? But you see this right here specifically is what EUI-65 did. It padded what? It took the MAC address of the interface and it padded it with triple FE. And you may be saying, oh, Laz is lying. Interface F0/0. Okay. Why would I do that? Do show int F0/0. All right. Here's that IP address. Oh, look, it's pretty cool. We can see it right here. So we got E0 right here. Okay. Here's E0 right here. And then We have an F. Here is an F. We have a 7. Here's a 7. Here's the triple FE that I was telling you about. This is EUI. That's the one that put it in there. Then we have an E. No, not the E. Sorry. Triple FE. Sorry. Then we have a C. Okay, C5, C5. And AC01, AC01. So you see, it took the MAC address of this interface, okay, and just put triple FE in between it. Why? Why would it do such a thing? Because an IPv6 address is 128 bits, so I had to get it from somewhere. Now, with Microsoft, it generates it randomly. Some people are like, oh my God, now you know my IP address and you know my MAC address. You're going to hack me. Well, secure your stuff, okay? I'm being nice. Secure things. Have good firewall policies, okay? So they won't get to you. But you might be wondering, you said, well, last man, there's a 2 here. And it starts with an E up here, but down here it starts with 2 zeros. That's because all these are off. But the 7th bit on that guy got turned on, okay? And he became 2, because that's the bit value, 2. That's where you get that 2 from. That's the UL bit, okay? So it got turned on because it's a public address, all right? There's others too, assigning an IP address to a router. There's many ways of doing it. This is just one of many methods. And as we go along, we start creating more, not complex. I'm not going to make this all crazy. I want you to understand what you're doing, all right? So, but assigning an IP address to an interface, it is not difficult at all. And keep in mind, with now it's Ethernet. It's not serial where you gotta put in clock rates and all that silliness. Now all that's gone away. Everything is multicast. FF, right? Everything that starts with FF is a multicast. I wonder if I can do a debug IP rip here. Let me see. Debug. Oh, I spelled that wrong. All right, there you go. Debug IP rip. All right, so that's all. We gotta wait a little bit. That hasn't changed with RIP. I don't care. The configuration is different. It's a lot easier. You don't have to worry about what network am I on, what network am I, what's my network statement. You don't have to worry about that. You just put, IP and go to the interface and go IPv6 RIP1 enable, and then you're good to go. All right, and that's awesome. All right, but the timers are still the same. You gotta wait 30 seconds. All right, in order to go ahead and do that. Now, for whatever friggin' reason is, these 30 seconds are taking long as hell. So let me see if I can kind of kick. Oh, it's not connected to anybody. All right, so let's do it on the real router, shall we? I'm gonna do a ping of death. I wonder. Let me do an up arrow. What am I pinging myself? Oh, I ping my gateway. Okay. Let's ping 1, and then let's ping 2. Right, that's the other one. That's the other guy on the other side. All right. So I wonder if I can do a -T here. I never tried it with an IPv6. Yeah, no, can't do it. Maybe let's say if it's case sensitive. Let's see, -T. Nah, yeah, you can't do it. Okay. All right. So I pinged it. All right. Let me close this. Minimize this. Go ahead here. Doing IP debug since I do have an actual network here. I can do enable. I forgot I was by myself. I was waiting for it. Okay, IP debug IPv6. I did IP before. Debug IPv6 RIP. Really? Oh, neighbor discovery. How about that? ICMP neighbor discovery debugging is on. Well, that's good because neighbor discovery is part of ICMP v6. All right, there's no more ARPs or anything like that, even though there is updates. But that's okay. We're doing IPv6 neighbor discovery. Let's see if we see any kind of discovery going on. All right, let's do also. Should I do a debug all? Debug. No, there's no debug all. They don't let me. And you see they only have OSPF debug. But you see, completely different. Okay, IPv6. All right, and stateful inspection nodes and stuff. Neighbor discovery, that didn't work. TCP. Okay, well, I don't have OSPF. Okay. All right, well, anyway, so one of the things I wanted you to see was the 224.0.0, not the 224, the FF02::9 going back and forth. So you can see that, you can do a debug IP rip, IPv6 rip, I'm sorry. And you can go, or rip NG, I don't know, maybe you have to type that. And you can see that going back and forth with the updates. The updates still exist. That has not changed. But again, careful. Be very careful what you're looking at, because this that I found is wrong, okay, completely. Your book, page 551, volume 1, chapter, what chapter is this? Chapter 23, all right, in the note, it says if you use an FD, RFC 4193 requires the 8th bit of it to be on, and I showed it to you right here. This is how you get D, right? It says CIDR 8. Right, this is how you get D, because this is 8 and 4 is 12 and 1 is 13. And that's what D is, right? Because you got A, B, C, D, 10, 11, 12, 13. I mean, it's simple math, all right? That's how you get 13. So they're correct. The RFC, I mean, they can't be wrong, right? That's correct. Here, though, is where I say, okay, well, wait a minute. This is C. So this is F, okay. C is A, B, C, okay. 10, 11, 12. That's 10, 11, 12. Okay, so 8 and 4 is 12, right? 9, 10, 11, 12. Yeah, 8 and 4 is 12. So these two on right here. So I guess they're including this 0 on it as well for whatever friggin' reason. All right, but it's a 7 and this is an 8. That's the way it is. That's just the way it is, okay? And that is as per your RFC 4391 for you RFC freaks out there. But yeah, and as far as the subnetting is concerned, here I used the 50 because I did it previously. I remember in the previous lecture that I actually subnetted an Excel spreadsheet, and we started with the 50 and I went to a 54, and then we can go ahead and do that. But that's subnetting. I could have just said, 1064 like I did in router 4, and then 2, then 3, then 4. It doesn't really mean whatever the hell you want with IPv6. Just careful because in that subnetting section or field, it's very easy. Like right here. No, I'm going to show you there. Yeah, I'll show you here. In this field right here, it's very easy to overlap. This is why ICMP v6 sends out, you do their neighbor discovery, neighbor solicitations, router advertisements, router solicitations, and then you have DAD, duplicate address detection. It's looking at here, really. It's looking here to see if there's any duplicate addresses on the network. Not that there's going to be a duplicate. There's just an impossibility to have an actual interface ID that's the same on another side. If you did, what are you? You're high. I mean, there's 15 quintillion addresses that you can use per subnet. So come on, all right? So no, they're looking at the subnet section to see if there's any duplicate addresses, and there is very easy to overlap if you are doing true subnetting, okay, that you're actually going in, because 64 is not subnetting nothing. All you're doing is breaking it in half, okay? It's like I said, 192.168, 1.0, 2.0, 3.0, 4.0. We're using the default mask of 24. That's not subnetting, okay? 28, 27, in IPv4, 28, 27, 252, using that, right? Or a 30, that's subnetting. 24 is not subnetting with a Class C. It's not. Okay? So anyway, but this is it. This is as hard as it gets. But I really wanted to get a good understanding of how, because of that damn question that kept me up last night. Okay? At the beginning of your chapter, in chapter 3, I mean, it's obviously based on the in all your answers, and and answers in questions 1 through 5. All right, everything has to deal with the global address. All right, just read you a random question from the volume 1. Which of the following IPv6 addresses appears to be a global unicast address based on its first few hex digits? Well, they got an FE80. We know that's a link local. They got an but look, they got an FD. But, oh, yeah, but they got an FD. Let me look at question 5. Which part of the address is considered a global ID of the unique local address? And question 2 is which IPv6 address or addresses, maybe I should have marked DC as well. No. Question 2 is A, which is 3123, is which of the following IPv6 addresses appears to be a global unicast address based on its first few hex digit? So why isn't F00 wrong? Why is FD, FF is a multicast, FD, AD, oh, that's wrong. Why is that wrong? It's FD. So it has to be F00? Is that what you're saying? So if I put something else here, it's going to give me an error? I'm going to change it right now. What do they have there? They have FD, dad. D-A-D, dad. Let's see if that's wrong. It didn't give me an error. So yeah, Confucius. Okay, so I don't know what to tell you guys. Just memorize, look at your RFCs. This time I am encouraging you to be Sherlock Holmes, go into the RFCs, all right, register those books, go into their videos to gain a better understanding, hopefully, because here they have a little table, table 23-2, some types of IPv6 addresses and their first hex digits. So global unicast is 2 or 3, okay? All not otherwise reserved today, okay? Unique local, FD, and multicast, FF, and then link local, FE. Okay, so in answering question 2, why isn't C an answer? Is it because it's global? Okay, global, there you go. Global unique address. That's why, global unique address. It's 2 or 3. Where 5, it's considered a global ID of a unique local address. So a unique local address is FD. So be tricky, these questions, okay? Be very careful how you're reading these questions and what they're really asking you, because one thing they can be asking you about your global prefix, which is just a statement of which part of the address you're looking at, and the other one is a globally unique address, which is a public address. So you see the terminology, even though they're saying it's overlapping, the hell it is. They're going a lot deeper and being a lot trickier. At least the author is, this Cisco, in their disclaimer. Where is it? I think I read it in the previous one. The opinions expressed in this book belong to the author and not necessarily those of Cisco Systems or Lazaro J. Diaz. Okay, but when you're doing this, yeah, please, if you are going to take the CCNA 200-301, do not skim over any chapter. Go into every last little detail. Question each friggin' question. Go to your RFCs, register your books, and see what's going on. Okay, but again, you saw that it's not that difficult to route. We'll be getting into a lot deeper, more routing protocols, and we'll use different addresses and stuff like that. So you can see that this is not some crazy stuff that's going on. Okay, and this particular chapter is pretty thin. All right, pretty thin overall on what they're doing. Let me see here. The need for a globally unique local addresses. And here they are: FD-E9, FD-F0, FD-00. All right, but you got to be very careful. And again, they always point back to that RFC 4193 because where did this? I didn't do this. It was online. I didn't do it. I just snippeted it. This is wrong. It's wrong, guys. Wrong. All right. because according to the RFC, this bit must be on if you're using FD because this is a 13. So that's what the prefix lengths mean. All right, it's that you're counting bits left to right. Okay, FFFF, then C, then whatever it is. All right, you're counting those bit values. That's it. And again, the interface ID, you can put it in statically. You can use whatever. You can just start the hex table 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, and then just make up whatever you want as you go along. It doesn't really freaking matter. All right, you're never going to be the same. I mean, come on. All right, or you just use the EUI64. Let it make up its own IPv6 address. So again, I think the whole purpose of these global addresses, where there's global, meaning public addresses, there's 2, the range 20000 to 3FFF. It's just the fact that that's just the IANA, and then your ISP is whoever they are, whatever the IANA says they are, and then your ISP tells you who you are. Yeah, they're trying to build a hierarchy. They try to build a hierarchy. So if you're looking at one subnet, you're looking at all the addresses already. So there's no real summarization here. Can you imagine trying to summarize all those 65,000 subnets? That's not going to happen. All right, so this is what they're trying to do. Build that hierarchy so you can take a look at all the addresses. Because I cannot see myself putting in a 48-bit prefix length. I can't see that unless I just can't, because I'm omitting. I mean, I can see that being company 1, company 2, and company 3, but what is the subnet? That is the internet portion of it. Okay, but now we need to do it for the internally. We need to understand what subnet is that we're using. And again, you can do it. I tell everybody do 1000. You can do 0001, 0002. 0003, and you keep going that way, and then you start incrementing to the left. Okay, resetting the next one to 0, and so forth and so forth. They keep going. That's how you got these 15 quintillion addresses. It's insane. All right, so you can do that. So when you get to F, resets to 0. The next one is 1, then 1 1, and 1 2, and 1 3, and 1 4. Then F again 2, and so forth and so on. So it's it's interesting. But we'll be doing a bigger labs, but you just saw on that 1841 router right here. That was pretty easy. And enabling RIP, which apparently is not part of your 301 address or 301 certification exam, is OSPF. But when we get to some real routing, you'll see how things are going on. I'll be doing labs for you. And remember that you will have a bonus section in this course that I will have in there for you that would include things that are not on the 301, supposedly. They are not on this 301 test. But I'm going to put them in that bonus section. If it's up to you, if you want to take a look at it or not. But I'm going to put them in there because I think they're so relevant for real world purposes, practices, and so that you need to know. All right. But that's it. That's all there's to it. I just want you to get a good grasp on this FD, FC crap. Okay. So you know what's what and what prefix length there truly are, according to their RFCs, and the range for globally unique addresses. These are unique local addresses, public, private. All right. Obviously, here we don't care. We don't need to run that. We're sharing routing tables. All right. So it doesn't really matter. Just like an IPv4, and we can still ping across. We pretend that we're doing that, but we're not. All right. It's translating. You can see the translation, but yeah. All right. That's it for this one. Assigning IP addresses. I just did a basic thing with RIP, which you're not going to do in your test. All right, it will be OSPF, but we'll get into OSPF. Don't worry. All right, during the course. But once this course is done, remember the bonus section. That's where all the other good stuff is going to be there. Okay, I'll see everybody in the next one.